Hi there everybody, so we are looking at standard form today. So we're going to look at converting to and from standard form and then probably look at some calculations that involve a standard form. Alright, so first of all, what is standard form? Well, standard form is a way of representing very, very big numbers or very, very small numbers. But to be consistent with everybody else, and hence the word standard form, is that you can only have a number between, which is basically between 1 and 10. So one number before the decimal point, and then it needs to be a multiple of 10 to justify the size of it. Okay, so let's look at some examples in terms of how you do that. So if I ask you to write 2,400 in standard form, well, if I leave one number before the decimal point, then I'm going to put the decimal point here, so 2.4. All right, so it's going to be 2.4 times 10 to the something. And again, this is very much standard form kind of speak, but it's a case of how many tens do I need here to make this number. All right, well, if I look at my decimal point being here, you'll notice it's 1, 2, 3. So what happened is I've moved my decimal point, which is currently here, 1, 2, 3 along. So it's going to be to the power 3, because 2.4 times 10 cubed is 2,400. All right, so 2,400 in standard form is 2.4 times 10 cubed. If you've got a small number, well, I'm still going to do something times 10 to the something, because that's standard form. But what's actually happened here is, well, where am I going to put my decimal point? Well, decimal point is going to go here, all right, because I want one number before the decimal point, so it's going to be 5.67, okay? And then because I'm going to do times 10 to the something, well, I'm not going to times it by 10 something, because it's going to get bigger and bigger and bigger. But of course, standard form says that I've got to times it by something. So this is the only thing I can manipulate, is the power. Well, if I know my rules of indices, and hopefully I do, but maybe you don't, and then probably please look at the indices. Well, if I want to divide by a 10, then this number here needs to be negative. All right. So what I'm going to do is I'm going to move this 2 down, and then essentially times it by 10 to the minus 2. All right. All right. So that's how we write it when the number is small and my decimal point moves in the opposite direction. All right. 10 to the minus 2. Okay. So converting from standard form to ordinary numbers, well, this is the idea of going back, as what we just kind of said. So if I said I've got 10 to the 5 in ordinary numbers, then what I'm going to do is I need to basically times it by 10 5 times. So what's going to happen to my decimal point? It's going to go 1, 2, 3, 4, 5. Well, how many zeros is that going to need? It's going to need basically another 3 after I've moved the 4 and 3 across as well. All right, so 843,000 is the actual size of that number. All right, so times it by 10 5 times it by 100,000. So again, I moved 1, 2 to get to 843, and then I need another 3 to get 5. All right, so this one, so it's 10 to the minus 4 as an ordinary number. So again, this is going to be very small. So I'm going to divide it by 10 4 times. Okay, so there you go, divided by 10 4 times. And then when I move it along, again, same kind of idea. The 2 is going to go, that's one of them. And then I'm going to need another 3 zeros to go across. So hence the 1, 2, 3, obviously 4 digits there. So if my decimal point was there, 1, 2, 3, 4, and that's where the minus 4 comes. So I can just double check it again. All right, so that is to and from standard form. If you are calculating with standard form, then often it's easy to convert back to ordinary numbers sometimes, and then sometimes not. So it really kind of depends here. All right, so if I've got 2.3 times 10 to the 5 plus 5 times 10 to the 4, well, these powers are different, which makes it a little bit more awkward. So it actually might be easier just to convert it to normal numbers. All right, so times that by, obviously, 10 5 times. Okay, it gives you 230,000. Times 5 by 10 4 times, which gives you 50,000. Well, if I'm going to add those two, well, that's quite easy. It's going to be 280,000. If you then have to leave it in standard form, then I can literally think back. So 1, 2, 3, 4, 5. So it'd be 2.8 times 10 to the 5. All right, so that's one way of doing it. Takeaway, same kind of process. So if we're going to convert it to normal numbers, so 580,000 take away 3,200, it's going to give you 576,800. And of course, converting it back, it's going to be 5.768 times 10 to the 5. All right, so that's an option. Turn it back to normal numbers. Other options are multiplying and dividing. You can rearrange the powers of 10 to make the calculation easier. All right, so here you got 5 times 10 to the 5. and because this time we are not adding or subtracting, we are multiplying, then I can bring these two numbers together, the 5 and the 3.2, and also the tens and powers of tens. So this is about manipulating a little bit. So let's rearrange to put the numbers first. So 5 times 3.2, and then these second. Okay. So if I times 5 times 3.2, that's going to give me 16. And then if I times these together, it's going to give me 10 to the power of 8 using indices rules. All right, so 16 times 10 to the power of 8. But I can't leave my answer like this standard form because I can't leave 16. So I need to take a 10 off this and put it onto this. So divide this by 10. So therefore add onto that. So that's going to give me 1.6 times 10 to the 8. Because that's basically, I need to leave it between 1 and 10, don't I? So that's going to give me 1.6 times 10 to the 9 as my final answer. All right, so you can manipulate standard form, especially when your time's in, like this, to kind of get what you need. All right. Now, if you're a bit rusty or not quite sure, then please do go to, obviously, maths-school.co.uk website. Link is at the bottom to practice these kind of questions and, of course, to revisit any videos and content. Thanks for listening.